Welcome to part 5 of lesson 4.1. 4.1, you might be thinking, man, it's really long, it's really dragging on. But I think this is the last difficult concept that you're going to have to deal with, okay? Let's get this started. Sorry about my face being on your screen. Somehow my computer has some issues, so this is the best I could do. So you can bear with me, okay? So we just finished part 4, and now we're at linear and angular speed. Now, the sound of linear and angular speed, it sounds so difficult, right? And I also want you to remember that it looks like, oh, linear speed, here's a formula, right? Oh, angular speed, here's a formula. But I want you to know something. These are not formulas. These are not formulas, okay? I want you to think of these as concepts. So for example, okay, pretend my face, okay? It's pretty circular. Pretend there's something that's crawling around my face, okay? Okay, crawling all over my face. All right. How fast is this little thing walking or crawling around my face? How fast, right? What's the linear speed? Like, for example, linear speed means how much distance is this creature covering all around my face? Right? How much distance is it covering per time? And that's linear speed. Okay? And that's why it's arc length, because isn't this exactly what we just talked about? It's the arc length, right? The act of moving around my face. It's the crust, right? How much crust is it covering per time? That's why it's distance over time, or r theta over time. But wait, as this creature is going around my face, isn't it covering some sort of angle? So like, for example, it started at 0. If I go this much, a third at 60 degrees, and so forth, right? Or pi over 3. We're going to talk in radians, right? So pi over 2, pi, 3 pi over 2, and all across, that's a whole 2 pi, right? So it's also traveling some sort of angular over time. How much angle is it covering over time? And that's when you have angular speed, which is how much angle is it covering over time or per time. And that's why it's radian over time, because it's always radian over time. Time could be, I don't know, years, seconds, minutes. Distance could be, right? Distance could be feet, meters, yards, however you want to discuss it, and whatever will be presented to you per time. But do you see the difference, and do you understand the difference between linear and angular speed? Linear speed, again, let's recap, is how much distance is something that's going around in a circular motion. How much distance is it covering per time? Angular speed, how much angle is it covering over time? So now I want to give you something. I want you to look at a Ferris wheel right now. Okay, a Ferris wheel is huge, right? It's huge. Actually, you know what? Let's do something that you can actually see. Look at my face, okay? And look at my watch, okay? Look at the face of my watch. Now, if an ant was crawling around my face, is ant A covering the same length as ant B that's going around my watch? Of course not. This ant is crawling a lot more. So linear speed is not constant. Okay? How about angular speed? This ant, right? This ant is going around, right? In angle. And this ant is also going around. But what if I have, you know what, for this example, actually, you know what? Let's pretend a big clock and a small clock. That's better, okay? Big clock, if you go around, the second hand is going around this clock, it's covering a lot more length, right? Because the clock is bigger. Rather than this clock, it's a lot smaller. But how about angular speed? A clock, when a minute hand goes around the whole hour, isn't it covering the same angle and speed, right? Angular speed as a clock that's smaller or a watch that's smaller. Okay, so I want you to think about that. Now, with that, I want you to understand this is not using a formula and plugging and shoving in numbers, okay? It's all about stoichiometry. How many of you guys are really good at chemistry? And if you guys remember, like moles, milliliter, right? All that stoichiometry stuff, okay? So we're going to do stoichiometry here. But before we go on to stoichiometry and get to the real stuff, I want you to think of rotational speed. Rotational speed, it means it's going around in circles, right? Rotation means it's going around, okay? Rotational speed. these are just kind of like random facts that you should keep in mind and things that we're expecting from you. Rotational speed is revolutions per time. For example, how many revolutions did it take? I'm sorry, one revolution, how long did it take? Less than a second, right? One revolution per time. One revolution per time. Now, a couple of things. If I go around one revolution, how much linear or how much distance did I cover? Right? How much distance did I cover? Right? Didn't I cover a circumference over time? But that circumference is 2 pi r over time. Okay? So 2 pi r over time. One revolution is 2 pi r over time. But another thing to keep in mind is, if I go around one time on one revolution, how much angle did I cover? You're right. I covered 2 pi over time. How much angle did I cover? 2 pi. And that stays consistent no matter what. Right? I always cover 2 pi. I always cover 2 pi if I go around in a circle. But I don't always cover 2 pi r because the size matters. For example, my face, the clock at school. Right? Same angular amount per one revolution, but not linear. Okay, not distance. So let's try an example. So I don't know if you guys know this, but Mr. V and Ms. Chang, we drive our scooter when the weather is nice to work. Okay, but on the weekends when we're not teaching or working, we like to go around in circles in our Vespa. Whee! Do like wheelies. Okay. Now, again, keep in mind stoichiometry. Okay. Now, we're gonna go around in a circular runway at 3 revolutions per minute. A circular runway, 3 revolutions. Now, I want to ask you, are we going fast? 3 revolutions per minute. Think about that. I bet you if you're thinking properly, you're like, 3 revolutions per minute? I mean, that means like about third, right? If you did like 20 seconds, right? 20 seconds per one revolution. Is it a big circular runway or a small? Think about all those questions, okay? If the radius of the runway is 175 meters, find the linear speed in meters per second. Here's another thing that we're going to do always. I'm always going to specify what answer I want. Meters per second. So you know what? We're going to actually start that way. Meters per sec. We're always going to start with what's given and what you want to end up with. Okay? What's given and what you want to end up with. So I'm going to start this way. Let's see what else was given. We given 3 revolutions per minute. So I'm going to start there too. 3 revolution per minute. Our goal, as you guys maybe have taken chemistry, is to cross out everything so we get to meters per second with revolutions per minute. You're like, what the factor? How is that going to be possible? It is. Watch this, okay? So wait, let's start easy. I don't want minutes. I want secs, right? So what am I going to do? You know, I want seconds or sec, so I go here. Okay, but you also know that in 1 minute, it's 60 secs. So what are we going to do? We got our first thing to cancel out. Minutes go away. Yes! Guess what, everyone? We're halfway there because we got secs here and we got secs there. Awesome, okay? All right, now, how am I going to get meters up here? I have revolution. I got to get rid of revolution. So you know what I'm going to do? I'm going to force it. Revolution better go here because I want revolution to be hiya. Okay? Now, how do I do that? But wait a minute. If I go around 1 revolution with Mr. V, if I go around 1 revolution, this is meters, right? How much meter have I covered? You're right. It's 2 pi r, right? I've covered 1 circumference of that circular runway. So it's going to be 2 pi and 175 meter. I'm going to put a meter there just so you guys can see that at circumference. Revolution, revolution. What are we left with? All that to multiply on top, which becomes meters, and all that to multiply in the denominator, which becomes a second. And here's my final answer, ladies and gentlemen. I got 17.5 pi meters per second. That's how much we're traveling. That's how fast we're traveling. That's how much distance we're covering every second. But now I'm going to ask you the question. If 17.5 pi is an exact answer, but are you able to tell me right now how fast or how big this runway is really? So I think this makes more sense if we actually get the approximate answer, which is 54.978 meters per second. Now, to show you how fast or how big this runway is, to give you some perspective, Miss Chang, I told you earlier that I'm about 5 feet if I'm wearing heels, but I'm also about 150 centimeters about, or 1.5 meters. So imagine this runway, okay? Imagine this runway. Now, with this skill, you're going to try this worksheet here. This is called, wrong worksheet. It's a, where'd it go? Let's look for it. It's 4.1, linear and angular problems. You're gonna try a few of these, okay? Just try a few, but let's look at the one that's already done for you. Check this one out. Okay, you're gonna try a few. I'm gonna specify it on the homework. You'll see that, okay? Let's, again, we start, I'm gonna highlight what we start with. Find the angular speed of a truck with wheels 5 feet radius in radians per minute. That's final answer. So we're going to start with this, right? We're going to start here, radians per minute. Truck's wheels are rotating at 65 miles per hour. So we're going to start again here. With that, everything in between here is just trying to force this. How do you get minutes? Oh, it's 1 hour, 60 minutes. Yes, we're almost there. Now, we have miles here, but we want radians, right? What the factor? We want miles? We want radians though, right? So what do? We got to get rid of miles first. We know that 5280 feet per 1 mile. Haya, gone. But now we have feet because our radius was given in feet. That's why we knew we needed everything in feet. Now, I go here. 1 revolution, I know I go around 1 circumference, which is 2 pi r, and that's 2 pi and 5 feet radius. And then I have miles are gone, but my miles are gone. Now feet are gone. I have revolution, which is gone because I know that in 1 revolution, I've traveled 2 pi radians. And I get 1144 radians per minute, okay? Okay, so just try a few of these questions here. I know you'll come with questions, but that's okay. That's what I'm here for, okay? Do your best, and let's go back here, all right? And you're going to skip this part here. Yay, okay?